Hey there, my name is Zach Gurberg, and today in this video I'll be presenting a quick introduction into some of the tools and features of Imalytics Preclinical. The purpose of this video is not to be a tutorial or a guide into these features, but mostly just to present them and several use cases of them. So over here what we've got is a PET-CT dynamic dataset of a mouse. So we've got our CT as our underlay over here and our PET as our overlay. And so this is a dynamic data set. So what we can do is we can scroll through different time indices and see tracer accumulation throughout time. So what we're going to be doing with this data set is just segmenting some of the key areas and demonstrating some of those segmentation tools used. So what we can start with is creating a new class called bone. And we'll be doing this segmentation from the CT. So we can hide our PET just like that. And what we'll do is we'll adjust the windowing of our underlay, which is our CT, so that we can see the bone in clarity that we like without too much noise. So something just like this will be a good starting place. And so what we'll do is we'll perform a thresholding operation above center so that we get everything from our ISO surface segmented towards our bone class, just like this. And so now we can clean up our bone class by removing things from it. So for instance, we can do a find small components operation with a max volume of, let's say, 3 millimeters cubed. So anything that is under 3 millimeters cubed will get transferred from bone to unclassified. So that removed a decent amount of the noise, but we've got still this region over here. And what we can do is we can use our paint bucket tool to perform a similar operation. And this goes by volume of the region. So just like that, in a few clicks, we've got our bone in detail that is sufficient. And what we can do is we can also remove or change the class of some of these features. So for instance, we can add a new class called legs, and we can segment just the lower leg, let's say, of the skeleton towards the new class, which is legs class. So just like that, it becomes purple. And this is a paintbrush tool that we can use in 3D or in 2D. And just like that, we've got our lower leg segmented. We can now proceed to doing some segmentation from our our PET, like this. And we can do this in 2 dimensions. So what we'll do is we'll add a new class called heart and go for segmenting the heart. So we're going to scroll through the time indices of our PET until we find a time index that shows the heart with a decent amount of accumulation. We'll open up our 2D views over here, just like this. And what we can do is we can hone in on a region of the skeleton that shows the heart, like this, using Control-Click. As we slice through our axial slices, we can see this red cursor on the right moving along the axial axis to give us an indication of where we are in 3D space. And we can use our ISO tool here to perform the segmentation of the heart with 1 click. So just like that, we get the heart segmented. And what we can notice is that there is a hole in the middle of the heart, but we can remove this using a morphologic closing operation of, let's say, 15 voxels. And just like that, the hole in the heart is gone. We can continue to do this for our kidneys. So we can add a new class called kidneys. And we can click to obtain our kidney just like that. And we can grab our other one over here, like that. And so we can also perform a morphologic dilation of these to make them a little bit bigger. We can do by 3 to make them a little bit bigger like that. We can then go for our bladder like this, add a new class called bladder, and click just like that. And we can see our segmentation now in 3D, and everything seems to look just right. So now that we've performed our segmentation, we can proceed to doing our quantification, and this is right up here in the statistics menu. So if we've got our underlay selected, we'll get our statistics for our CT, so in Hounsfield units. But if we select our PET over here, we'll get our statistics in kilobecquerels per cc. And this is a dynamic data set, so we get all the different time indices with our mean attenuation. We can also view this as a graph like this, and these can be exported as PNGs or CSVs for later pipeline applications. If we'd like to convert this to SUV or percent ID per gram or ML, we can do an SUV calibration, which takes 1 click due to loading all of this info from the DICOM header. So if I press OK, our units now turn into SUV, and this goes for our class statistics as well. So we can see mean SUV over here, mean SUV over here. And so clearly we're able to work with Imalytics to perform some 3D segmentations in real time without latency of fairly large data sets. Now, of course, learning a new software is a tedious task, but with Imalytics, we've done our best to make it as intuitive as possible, and I'm sure you'll find that it is quite easy to learn the software due to some of the tip features that we've implemented. So for instance, if you hover over any tool in Imalytics, you get a tooltip menu with a guide of how this tool works. So this goes for any tools, no matter how simple as a zoom tool, or even if you go into like the kinetics menu, which is obviously a more complicated submenu, you get a full mathematical description of the model used for the kinetic parameter estimation. This also goes hand in hand with some of the tutorials that we've got over here on the right. Now, these tutorials go over some of the more basic features as well as more of the advanced features, and they come with both a video and an example data set. So if you click on the video, you'll get a video describing cropping, but you can also use an example data set to practice. So another distinguishing feature of Imalytics is the cloud availability. So we are capable of providing cloud access to the Microsoft Azure Cloud, which is a very well-renowned and secure cloud service provider. They have servers located all throughout the world, so no matter what, you are guaranteed to be connected to the most local server, and this provides a secure and very fast connection for latency-free processing of large datasets. The connection is always to a very, very powerful PC with great graphics processing capabilities and lots of RAM, so you're guaranteed to be able to process even your greatest sized datasets in great time. This is a particularly useful option for imaging centers that rent out their local workstation usage to people from different departments that are trying to perform their own image analysis. So rather than booking out your local workstation usage, you will provide a cloud license to them so that they can perform their image analysis from home. So just to conclude, I hope that this short video allowed you to see what some of the main differentiators of Imalytics are, as well as some of the features that we've integrated that may accelerate some of your image analysis workflows. The three main points I think to take away is that Imalytics runs on one of the most modern GPU-optimized architectures, and this allows you to process large data sets with 3D manipulations in real time, so it's completely latency-free. The software is extremely intuitive and easy to learn due to the countless hours spent on the UI, including the icons, some of the workflows, the tutorials, and the tip menus that we've integrated at every corner. And lastly, the cloud network offering, which simplifies collaboration and remote working without the need of an IT department. So as always, if you have any questions, please feel free to let us know. You can find our contact info in the video description or at the bottom of this webpage, and we hope to hear from you soon. Bye now.